Okay, hello students. Here I'm working on Algebra 2, Unit 4, and today I'm working on Lesson 14. So I'll just walk through some of the uh, tasks. The main students, so the students facing let's solve. So you're supposed to, so what are we doing today is solving equation with logarithm, and I can solve simple exponential equation with logarithm. So let's see. Usually, we are going to use a lot of uh, logarithm, that means ln, the natural logarithm of x, which is written as ln of x, and it is read as the log to the base e of x, so it is the number y that makes the equation. So we've been already learning all this last 2 weeks, so let's go quickly. Uh, okay, the first question. See, so you're given, I want you to write this in your backside of the page, even though it doesn't show you this. Mm, so this one says, okay. So to solve equation, in order to solve this, a student by name Lynn writes the equation this way. Okay, let's see whether she does it correct. So that it is 5 times e raised to 3 equals 90. So the first thing is done. How did we get this? Is she divides 5 both sides. So when you divide 5 both sides, this goes away and you get e raised to equals 5 goes 1 times 5 and 4, 18. And that's correct. So she's right. And after that, she says, this is, so the question is, how did she get this? So the definition, so what is the definition of logarithm is b raised to x is equal to y. Let's say the exponential form, when you write in the logarithm form, it is x equals, we write logarithm, and the b goes as the base at the bottom, and then of y. So I think she's doing the right way, that instead of b, she uses the e. So she uses the, so instead of writing x, see the exponent in this case the exponent is 3a. So the 3a is logarithm to the base e of this number 18. And she's absolutely correct, right? And finally she divides this whole thing by 3, and she get a equals this answer, which is absolutely right. So only thing, one more thing I want to add here is, instead of log, whenever the base, if the base is used as, so this base e is used here, then we can also write this equals on ln of 18. So that's another way. This is called natural logarithm. The calculator, if you see those yellow calculators, and there will be log. I think there's ln here, and there's another one is log. So when I say log, if there's no base 10, but if it is ln, it is the logarithm to the base e. So hope that helps. So let's see the next one. So the next one is here. Okay, so there's a table given to us. Complete the table. Watch this. So you're supposed to change this to, okay, you're given exponential form. So this is changed to ln form. So remember, this means it is log to the base e of 1 equals 0. So that's what that means. So instead of writing log, and this number is natural number, special number, which remember is 2.7182. So that's the one we can directly say this part. So anything raised to 0 is 1, right? So we can change this and write logarithm of 1 to the base e answer. So in other words, we should always, it's like a formula here, that anytime we have logarithm, no matter what the base is, and if it is 1, it's always going to be 0. So that's kind of a rule. that logarithm of 1 is always, okay. So the first one is, so this was an example that is shown to the next one. What is this answer? How do we write this? So to write this, e raised to, this one is given, right? This part. So I'm going to write it. E raised to 1 is e, right? So we can write this in the log form, logarithm of e of of. So I think this has got messed up. So let me use something else. So the next one is this one, e raised to 1. So e raised to 1 is e, basically means, of course, we know that anything raised to 1 gives back the same thing. When you will put in the logarithms, the base, this is the base, this is the base goes down of this. So that goes right here, e is 1. So we write here, this answer is ln instead of, because the base is used is e, so we put ln of e is 1. So what did we learn from here also is ln, and suppose there is a e, is always be 1. What it means is logarithm of e to the base e is 1. In other words, this e ray, when you put, it's like you're pushing this up. Okay, you just push this up, so it goes up like there's the exponent, and you get this part as e. See, and we believe this. If we believe this, we should believe this. And if we know this, then we believe this also. So ln of e is always 1. So there's also going to be a rule which if I write logarithm of b, let's say, and there is a b and raised to x. So then if the base and this number is the same, we just cross out and that's how it is x. The next one, what about here? So c is e raised to minus 1 is 1 over e. That means instead of logarithm, I'll use ln, because now that you know this itself is like takes care by default of 1 over e. Answer is minus 1. That's all you're supposed to write here. Now in this case, the logarithm is given, see? So that means when you talk about ln, there is a base is e. So you put e raised to this number goes up as exponent equals 1 over e squared. That's it. This one, ln of 10 is x. So this is just kind of a lot of practice just to get used to the ln part. So remember again, I repeat that. So the trick is logarithm of x to the base e is same as writing ln of x. That's all it is. And one more thing, logarithm of x to the base 10. If the base is 10, there's no need to write anything, just write log x. The calculator does keeps this one. If you see the yellow one, you'll see that. So now I'm going to go directly to go to the practice problem. So the question number 1, solve each equation. Okay, so solve each equation without, so no calculators. Some of the solution will need to be expressed using logs. So sometimes you can't get the exact answer. So the first thing is in the first problem. So let me go up here and start with the first one. So the first one is 4 times 10 raised to x equals 400,000. So best is if there is an exponential, just keep it this one and you divide by the number. So both sides divide by 4. So this 4 goes away. And this, when you divide, will be 4 cancels one time. So this 0 will remain. So it is like 100,000. So let me write this again. Is 10 raised to x equals 100,000. And now what we can do is see that do not write in log form. Write in log. Why? Because remember this is 10 raised to x, and we know there are 1, 2, 3, 4, 5, 0. We can write is 5. See, now they have the same base. So if they have the same base, that means the exponent has to be same. So this part, that's the only way they will look alike. So x equals 5 and you're done. Second question, in this case you will see 10 raised to n plus 1 equals 1, right? And 1 is same as 10 raised to 0. Anything raised to 0 is 1. Now see this. So both the 10, 10 is the same. So n plus 1 is 0. And if you subtract, you get n equals minus 1. Done. This one also will do the same thing. 10 raised to 3n. There are 1, 2, 3, 4, 5, 6. So this is equal to 10 raised to 6. So this 10 and this 10 goes away. When you get 3n equals 6 divided by 3n equals 2. Done. So I'm just trying to, these are easy questions. I'm walking through quickly on them. Look at this question. Now 10 raised to p and there is a 725. Now we can't write this like how we did this earlier one. So what you do is change this to the, we'll change this is in the exponential form. We'll try to write in the logarithm form. When you write in the logarithm form, you write the logarithm, put this 10 at the base, that's the base. Now this is the output, right? That output becomes input here. And the input, which is P, which is right here, is P. And that's all it is. You're done. You're not supposed to do nothing. And the last one is this one. Let me clear this. Okay. So this one is you first divide by 6. Okay. So this goes away in a 10 raised to t. 6 divide 30, right? 60, sorry. And then you change this to, now you can't write 60, this 60 you can't write as 10 raised to something. So change it to logarithm. So write logarithm. Output becomes the input here. And the input t, which is up here, is like this. And the base goes 10. Done. This can be also written as log 60. 60. You don't even have to put the 10. See the 10 here. Let's go to the next. Question number 2, solve. So how do we solve this? The first thing we can do is there's a 10 here base, so we don't want anything before that. So let me write neatly. So d plus 2 equals 0.2. So first thing is I want to get away with the fraction. And the only option is multiply by 4 this side, multiply by 4 this side. This goes away. And you are left with 10 raised to d plus 2. And when you multiply, so this 4 times 0.25 is 1. Now the question is, two ways you can do writing in the log form also. But I will do easy way because the 1, because there's a 10 here, we can easily write this 1, we can put it, because there's a 10 here, so I can write it 10 raised to 0. So that means both bases are the same. So we can say, okay, if the bases are the same, then the exponent also has to be equal. See? So these are the exponents. So we can say d plus 2 equals 0. Subtract minus 2 and you get, what is this? So this goes away. D is minus 2 and you're done. Or you could also, let's see, once you reach this step, some of you may be saying, why don't you change this to the logarithm form and work it out? Let me see if I can do that. So this one, let's change it to the logarithm form. So when I put a log to the base 10, the output becomes the input and the input becomes the output. And then previous one, remember that it's like a rule that logarithm of 1 to the base is always 0. That's it. So this whole thing collapses to 0. So I'll put this is equal to 0 and you get the answer as minus 2 and you're done. So again, I repeat, in order to be to really get this correct answer, I want you to think of 2 raised to 3 is 8. Everybody knows, right? So that means when the input is 3 here, the output 8 is. So we go undo the thing and write logarithm. This 8, which is the output, becomes the input here. Okay. And because the 2 is there, that 2 is put down, and then this input becomes the output. So it's just asking how many times do you multiply 2 like this, or 2 raised to, of course, how many times you multiply this to get this 8. That's all it is. Common sense, and we all know the only ways there are three of them, 1, 2, and 3, and that's why the answer is 3. So this is an idea in case if you are still confused about what is the what's this exponential and the logarithm form, and I want to show it one more time just in case we still have time to understand this. Is you remember if I try to graph like this, what is y equals 2 raised to x? Remember, if I put x equals 0 here, so it is 2 raised to 0 is 1. So that's 0 is 1. But when you flip it, it becomes 1, 0 here. See? So this point is so this one is actually logarithm of 1 to the base 2. Now, if I put x equals, okay, I just put 0 is 1. Then if I put 1, 2 raised to 1 is 2. That means if this is 1, the answer is 2 here, right? And that means if this is 1 is 2, and you can just switch the thing and say 2 is 1. Okay? 2 is 1. So basically what I'm trying to show, if this graph is y equals 2 raised to x, the other graph is something like, say, goes like this, where this y-axis behaves like a vertical asymptote for this graph logarithm of 2 of x to the base 2. So the new graph, that's what I'm trying to say. It's like a reflection, both are reflected. So each of the input output here, they get reflected, and you can always do for everyone. So go back. So it's asking you, how do we write those put in the apostrophe form? How do you read this in two different ways? So this part, you're supposed to write this part, natural log. Now, when you talk about natural log, basically means logarithm to the base of 10 is y. That's it. But but we write this as ln because it is e, so ln and then of 10 is y. You're done. And another way to write is exponential. So this one, if this is the input and that's the output, so you use this base and say, hey, e raised to, this is the base. So e raised to the output goes up here equals the input, which goes this way. So these two things mean one and the same. So these two things are one and the same. So this is logarithm form, this is exponential form. So just because e is there, don't get confused. It's just a 2.7182. That's it. Next question. So you need to explain here why ln of, so what is the meaning of this? Let's see, ln of 1. Now the way they showed is wrong. They should have put at least 1 like this. Okay, what basically this means is logarithm of base is e of 1 is 0. Now you may get confused what is this, right? But we can change it to the exponential form. Now to change in the exponential, you need to know that the base is e, right? So that's the one I'm using, e. Then I'm going to use the black color as the output here. That becomes the input. And the red one, this one, equals to 1. See? And this is true. Why is this true? Anything raised to 0 is always any number raised to 0. That means b raised to 0 is 1, no matter what. And that's why. Uh, so the question will explain why this is 0 is because when it changes to e raised to 0 is 1. That's why. Because this e raised to this 0 is 1. See that? Again, I repeat. Uh, Pick the base, raise this up as the exponent, and then go like a. Can you see the arrow that I'm showing? So this is the arrow. You go this way. So e raised to 0 is 1. And that is true. So this is true. So if this is true, this is true. Or one more thing I want to show is that it's like if I want to graph and you want to graph what is this logarithm of 1 to the base e, that means this is 1, this is 2, and this is 3. It means at the point 1, it has to be like this. If the graph like this, 1 is 0. Let's go to the question number 5 is asking us logarithm of x to the base 10 is 6. So it's just asking how many tens do we multiply like this all the way to get 6, right? That's all that means. Now, if you see this, so question is what is the value of x? So we'll write, we don't know, right? Because 10 times 10 raised to 1 is 10, right? 10 raised to 2 is 100. So that means, and 10 raised to 0 is 1. So that means this 6, which is 6, 6, which is C, is between this one and this 10, right? So you want to know how many tens, so that means the number has to be between this 0 and 1. So first thing is let's write this in the exponential form. So in the exponential, we're asking the base, which is 10, right here. This is the 10, right? So this is the 10 raised to, so push this up and then go here. So 10 raised to 6 equals x. Okay, I made a mistake here. This question we asking how many 10s do we multiply all the way to get this x. That's the question, this x, not that. So, so how many 10s do we multiply to get this x? So the best way is we'll try to write in the exponential form. So we want to know what should be x, right? And you want to get answer as 6. So first step is change this to the exponential form. So this 10 raised to 6 equals x. That means there are 6 zeros. It means 1 million and you're done. So the question was 10, how many tens do we multiply? So 10 is, it's like saying 10 is multiplied 6 times. That's all it is. 10 is multiplied 6 times. So 10 times 10 times 10 times 10 times 10. So 6 of them, right? You get x. Hope that helps. Go to the next. For each equation log, so there you are given the log form, right? And you need to write in the exponential form. Again, I'm repeating this. Remember, if I write 2 raised to 3 is 8, and then you say, hey, logarithm of 8 e to the base 2 is 3. That's all it is. 5 raised to 2 is 25, right? So it means logarithm of the base here is 5. So put the 5 at the bottom, and then of 25, answer is 2. That's all it is. So you just have to write in the exponential form. So this one is given, logarithm is given. The base you see is the 2. So the first one, base is 2. So you say, okay, 2 raised to 4 is 16. That's it. Yes, that's all you're supposed to write. This one. The base is 3. So you write 3 is big one. Raised to the power 2 is 9. And you can see it's correct. This one is, bottom one is 5 raised to 1 equals this one. That is correct. This one is 10. So that's the 10 base. Push it up. Y equals 20. So and the last one is, so, so this one base is 2, right? So 2 raised to y equals this input becomes output. And you're done. Ha ha ha. Let's go to the next one. Last function is given. Look at this. So they give you something. What is the continuous growth rate of this? Remember now, this is coming to understand growth rate. Okay. Now, growth rate is either percent increase or percent decrease, right? So this is talking about growth is percentage, growth rate. But if it is growth factor is different. Whatever, let's say growth rate was, let's say R, factor is always B, which is 1 plus R, like that. If it is percent decrease, it is 1 minus R. Be careful. Now, there is a function given f of x in the exponential form, and especially e is used. So whenever is the, what does this basically means is the R, if you remember, if you compare this e raised to RT, R is, so the R is 0.07, which is 7 over 107%. So there is a percent increase of 7% increase. That's all that means. What is the continuous growth rate? Now the growth rate is totally different. Watch this. So let me wipe off this, clear everything here. Because they're asking you growth rate, it looks like there's no number is given before that. It means it is 1, maybe 1000. This means it is 1000, maybe e raised to, I can write this as 0 point, and the whole thing raised to x. Now what is this? X stands for? X is like 0, 1, 2, 3, and this is the growth factor. So on your computer, on your calculator, you can figure out what is that. By what factor does f grow when the input x increases by 1? That means what factor? So whatever that you get, this number. So e raised to 0.07. You put it on the Desmos or the calculator, you get the answer. That's all they're asking. I hope that helps. And again, I repeat. So this completes Unit 14. So Unit 4, Lesson 14, right? Cumulative practice problem, right? So hope that helps. And very soon now in the next class, we'll see. So in the next class, lesson 15, that is on Monday, we will see this using graph and logarithms to solve problems. So that's what we'll do. And then I'll try to see if I can combine this. It's the same thing but two different situations. See you guys. Thank you. And 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 so continue to learn, understand the concept. So my goal is to make you understand the concept. Okay. So make sure you write all the steps and get full 3.5. But if you want a 4, I'm going to question you, asking whether you really understand. And the 4 is basically whether you can apply in real situation. I can give an example where we can say, hey, so let's see, there is a money put in the bank, $150, and we want to put for continuously you want to grow the money, and I just put here 0.25 t, and you have to say, hey, what's the growth factor or what's the growth rate? If you can know that and how the graph will look like, that would be so great. So bye, take care. It's 10. It's almost 11 o'clock in the night time. I'm sleeping now, and I made this video.